Okay, in this video we've got an absolute value inequality. We have a few of them, and we want to solve them for x. And we need to be careful of answers that are no solutions and all real numbers. We're going to be exploring that in these few problems right now. So first things first, we see a negative number on the other side of the inequality. So that's kind of a red flag at first, because that usually means we've got all real numbers or no solution. But before we make that decision, we've got to isolate the absolute value bars, which means we got to box that off and get it by itself before we make that call. Okay, so let's add the 5. Let's add the 5 over here, and then we're left with negative 3 times the absolute value of x. That's going to be greater than or equal to negative 2 plus 5 is 3. Okay. Still want to isolate the absolute value bars, so let's divide out the multiplication of negative 3. So we divide that by negative 3, divide that by negative 3, so these cancel, and now I'm left with the absolute value of x, which is less than or equal to negative 1, because remember we're flipping this inequality symbol whenever we divide by a negative number. So now we've got the absolute value of x is less than or equal to negative 1, and since that's a negative number, that's another red flag. Okay, before we didn't have this isolated, but now we do. So is there any possible way, any number we plug in for x, is it possible that that could be less than negative 1, being a negative number? And no, it can't be. So we're going to actually call this no solution. Okay, now let's come up with another problem here. We've got the absolute value of 6 minus 5x over 4, and that's going to be greater than negative 7. So again, we see a negative number on the other side of the inequality symbol, so that would be like, oh, that's got to be no solution or all real numbers. But we need to get the absolute value bars isolated. So like before, we need to mess around with this side of the inequality symbol first. So let's get rid of the division of 4 by multiplying the left side by 4, which means we also have to multiply this side by 4. So now 4 over 4 cancels out, and we're left with the absolute value of 6 minus 5x. It's going to be greater than negative 7 times 4 is a negative 28. Okay, now it's isolated, but we still have a negative number on the other side of the inequality. So now we think, is there any number that we could plug in that will be, or that we would plug in for x that would make this side greater than negative 28? And truth be told is that any number you plug in for x, it'll be greater than a negative 28, because we're taking the absolute value of all this, and of course absolute value has to be positive, so it'll be greater than any negative number over here. So we'll say that that's all real numbers. Okay, let's do one more. Third problem, we've got 6 minus the absolute value of x minus 12, which is less than 10. So we want to isolate the absolute value bars. Okay, we got this here. Let's get rid of it. So let's subtract out 6, which means we subtract 6 from over there. Okay, we're left with the negative absolute value of x minus 12, which is going to be less than 10 minus 6 is 4. We still have a negative out in front, so we need to divide that out. So if we take all this, divide it by a negative 1, which means we divide this side by negative 1 as well, negative over a negative, that'll become a positive, so that negative in front will go away. Now we're left with the absolute value of x minus 12. Okay, it's going to be greater than, because we divided by a negative number, that inequality symbol had to flip, and that will be a negative 4. So again, we've got a negative number on the other side of the inequality symbol across from the absolute value expression. So if we plug in a number for x and then we take the absolute value of it, it's got to be greater than negative 4. So will that happen? Yeah, every time it'll happen. Any number, any real value that we plug in for x, it'll always be a positive number on this left side of the inequality symbol, because we have to take the absolute value of it. So that again is going to be all real numbers. So to basically sum all this up, whenever we have, say, the absolute value of any number, I won't say x, I'll just do the number sign. So the absolute value of any expression, and if it's going to be less than a negative number, okay, this is no solution. But if we take the absolute value of a number or expression or whatever, and it's greater than a negative number, then we're going to say all real numbers. Okay, so this is what you got to look for. You got to make sure that the absolute value expression is isolated by itself, and then on the other side it has to be a negative value, and if it's less than, it's no solution. If it's greater than, then it's all real numbers.